Go ahead and get started and do a couple of things with the calculator. We can do that while people are finishing up. And you guys that are still working, make it done as soon as you can, please. Okay, so you got your notes. You came up and picked up your notes, right? You got notes, homework, and then a little BFF sheet. We'll talk about what that is later. It will become truly your BFF. Let's look at 1.1 here. We'll talk about a couple of definition things in a second, but let's look at the graph or failure. Let's see what we're talking about by graph or failure. And this is something you probably have already looked at, but let's just make sure. So, let's get a standard window. So zoom 6. And let's graph that equation 4 divided by, now, I don't know about your calculator, but I have to put in parentheses. Mine don't automatically come up, and I want the whole 2x minus 3 to be in the denominator. So 4 divided by parentheses, 2x minus 3. Now, if yours automatically puts in parentheses, and you don't have to worry about it, but understand the order of operations. If you don't put parentheses around that denominator, what's the calculator going to do? Divide by 2x, and then subtract 3, because that's the normal order of operations, right? So make sure if you have more than one thing ever in any problem, more than one thing in your denominator, make sure that it is in parentheses. Okay, so let's hit graph. Now, I think you already understand this because I'm sure Mr. Miller made a big deal about it, but this curve has no x-intercepts. That like vertical line-like thing that's running down through the middle of it, it might look like you have an x-intercept, but you don't. What's going on? Who can tell me what's going on? In my picture, I see that. Do you all see that or not? If you have an old calculator, I know you do. If you have a new calculator, let me see your picture. You don't see it. You don't have any graph or failure. So all you people with new calculators, anybody have an old calculator besides me? Oh, you do, but you're working on something else. This is what mine says, because when my calculator draws left to right, it can't lift its pencil, so it shoots back up like this and comes back down. This is not part of the curve. What do we call this thing right here? It's called a vertical asymptote. Yep, that's an asymptote. It is not part of the graph. This thing has no x-intercepts, even though with my calculator, it looks like there is one. With you guys, you have a more sophisticated machine, so it doesn't have that issue. Okay, let's look at the next one, see if you guys can figure this one out with your fancy-dancy calculators. All right, let's sketch this one. And we want to find the zeros. So we got some kind of wild equation here, and we want to solve it. We want to find the x-intercepts. We may have to do a window adjustment, I'm not sure. Those are pretty big numbers. Oh, that's not 11, that's 1.1. I'm so sorry, that's 1.1. Okay, did you get something? I got a line over here, and then I got like a thing that looks like this. Is that what you got? So let's adjust our vertical window to see what's happening in between here. So I'm going to go ahead and, I don't know, what do you think for Y max? Let's try 100. Not enough. Let's try 500. There we go. So now I see a picture that looks like this. Comes up, goes around, comes down. Is that what you see? It looks better than mine, but you know, that's what you see, right? All right, we're looking for the zeros. The x-intercepts. What does it seem to you?
There's one x-intercept and two imaginary x-intercepts.
Well, does it touch there? It looks like it touches there.
No,
It doesn't touch there? Let's look at that again. You might, let's let our y men go down a ways. Oops. Boy, it sure looks like it touches to me. I changed my y min to get more of a square type screen, and it definitely looks like it touches to me.
With X? Where touches X?
It looks like this.
I took mine in.
No, it touches.
Yeah, I forgot.
All right, now, here is the point of the problem. I would like you to go back to your window. And I've already played with it for a little bit, so I'm gonna give you some numbers here. I just want you to put this in. So for your x min and max, do 4.9 and 5.5. So x min 4.9, x max 5.5. And then y min and max, do negative 0.1 and positive 0.1. Now, what we just did was zero in on this part of the graph. Does that make sense to you? I'm looking at x's basically between 4 and 5.5, 4.9 and 5.5. And my y's, I really shrunk it down. And what happens? What looked like it touched, actually it dips below. Yeah, there's 2 roots in there. That's what we call hidden behavior. When you first graph it, it sure looks like it's tangent right there. But upon closer examination, we actually have 2 zeros in there. So we have a total of 3. Does that make sense? Yes. Now, it is definitely possible for a curve to be tangent. It absolutely is possible. But what the authors of your textbook are trying to get you to understand is sometimes there's more to the picture than what you see. And if you're ever curious or wondering about it, you just have to change your window and look at the graph more in depth. I don't want to take the time to find these zeros. You know how to do that. Second calc 0. Now these are really close together, so make sure when you're doing your bounds over here that you are, staying within range. You can't get both of them in the same window. So min, or left bound, right bound, yes. Left bound, right bound, yes. And that'll give you those 2 roots. In, I think it's chapter 2, or you may have already talked about it last year. We're going to spend some time talking about how we know if we have a tangent, a point of tangency there. If we know we have a double root at that point. But right now, just want to make sure you understand 2 things about the calculator. There can be grapher, what they call failure. You guys don't have that with the asymptotes. And then you also have hidden behavior. 2 things to be on the lookout for. All right, a mathematical model. Any structure, anything you make, whether it's a picture, a table, an equation, any way you have of depicting a real life situation. So, remember our projectile motion formula? That's a mathematical model. That's a way of taking a real life situation and making it math. Anytime you do that, it's called a model. So when someone says to you, find a mathematical model for this situation, picture, table, equation, whatever you could come up with to turn the real life situation into a math problem. That's all a model is. Root, solution, x-intercept, and zero are all words for exactly the same thing. When we solve this equation and we find this, this, and this, those are roots of the equation, solutions of the equation, x-intercepts, or zeros. All of those words are interchangeable, okay? Easy. Now, number 2, took this straight out of your book. We have numerical, graphical, and algebraic models. So we got some tables set up, some graphs, and some algebra equations. Can you match them up? Can you match them up? Now the graphs are super simple to match with the equations, right? Because, first of all, one of the graphs is a curve. The only equation that's going to yield a curve is the third one, isn't it? X squared gives you a parabola. So the third equation goes with the first graph. Now, the other 2 equations are lines, right? But one of them has a positive y-intercept, and the other one has a negative y-intercept. So those are easy to match up. The top equation is the middle picture, and the middle equation is the bottom picture. I can tell that simply because of the y-intercepts. Now, fitting the points, the numerical models, the points to the pictures, maybe a little bit harder, but maybe not. Look at chart, or the first table, for example. What's happening to the x's in that table? The x's are going up by 2, all the way across, right? What are the y's doing? Going up by 6. So what does that mean? If your x's are always going up by 2 and your y's are always going up by 6, that's a line with a slope of 3, 6 over 2. So the top chart goes with the second equation. All right, what's happening in the second chart of values there? X is going up by 1, Y is going up by 2. That's linear, kids. When the X's and Y's are going up by exactly the same amount, that's linear. So that's a slope of 2. So the middle chart goes with the top equation, right? And that leaves the third chart to go with whatever's left. All right, good job. We'll pick up there tomorrow. What did you think of the quest? Easy. What? You think you got 60?
I hope so. I don't think so. I don't think so.
All right. Well, make sure you got your papers. Everybody's got your papers. Bring those tomorrow. Bring in your notebook. Nobody's Yes, we do.